Hey everybody. So here's the Punnett square we looked at last time. And remember, this is showing us a couple where the father has the normal phenotype, the normal trait, and the mother, she's got the albino trait. So the next question you might ask is, what do scientists actually use Punnett squares for? Because we can show the information of what happens when the father and the mother have children. Well, the whole point of a Punnett square is to predict the probabilities of what traits their children are going to have. So in our example here, remember the father, since he's homozygous, he's got two copies of the big A allele. He can only donate a big A allele to his children. So if this happens to be the sperm and the egg that fuse together, then the child's going to have a big A, little a allele. And in this particular example, it just happens that every single possible combination of sperm and egg are going to leave the exact same genotype, which means the phenotypes are all going to be the same as well. And what we do is we write that as a percentage or as a ratio.
So what we do in a Punnett square at the bottom is we list the possible genotypes and the possible phenotypes. And we write it as a percentage or a fraction. So in this case, it's pretty easy. So the possible genotypes in this family, well, all the children have to be big A little a. So we just write 100% big A little a. What are the possible phenotypes in children of this couple? Well, if they're always big A little a, remember that albinism is recessive, so all these children are going to be heterozygous, so they're going to be normal. They'll have the normal phenotype. So 100% of the children are going to have the normal phenotype as well. Okay, so that's how we set up a Punnett square, and we predict the genotypes and the phenotypes of the children. That's a really simple example. Let's do a different situation with some different parents. Okay, so in this case, let's have the mother and the father. Let's say both of them are heterozygous. So she's got the big A little a genotype, so does he. So they're both normal, but we call them carriers because their phenotype's normal, but they're each carrying a copy of the recessive allele here. Okay, so we'll set up our Punnett square again. Got our two-way table. We'll put the mother here and the father here. It doesn't matter which side you put the mother and the father on, the top or the side. So now, the mother, she can produce a gamete that either has the big A allele, but she can also make gametes that have the small A allele in. And the same for the father. So now it matters which two gametes join together when the mother and the father have children. So if these two gametes happen to come together, well then that child's going to have big A, big A. If these two gametes come together, that child's going to be heterozygous. The same if these two come together. And if these two gametes happen to come together, that child is homozygous recessive. So they're going to have albinism. Okay, so let's work out the percentages now. So the possible genotypes. Well, we can see we've got 25% will be big A, so a quarter. Big A. 50% are going to be heterozygous, because there's two possible ways to make a heterozygous child out of 4. 50% heterozygous. And then there's another 25% homozygous recessive. Small a, small a. Okay, that's only the genotypes though. The important thing is what are the phenotypes that are possible in the children. Because this is actually considering, are their children going to have albinism or not? So, remember, albinism is recessive, so this is the only child that's actually going to have albinism out of the 4. So remember, this is only probabilities. We're not saying if they have 4 children, 1 will be albino. It's still probabilities. So 25% are going to be albino, 75% are going to be normal. So we'll list the possible phenotypes and we'll say the probabilities of them too. 75% normal and 25% albino. So there is a way that 2 normal people can have an albino child if they're both carriers. Okay, so you can see here Punnett squares can be used for any combination of genotypes in the parents, and they'll help us to predict what possible genotypes and phenotypes their children are going to have.